Okay, good afternoon, good evening, whenever it is you happen to be looking at this. We are going to be looking at and studying polynomials. So first we have to know what a polynomial is. Let's make sure we're all on the same page. Poly means many, and when we say nomial, we're referring to many terms. So it's something plus something plus something, a whole bunch of things added together, and it's a linear combination of powers of x. So for instance, we're used to seeing polynomials as quadratics, things like 3x squared plus 2x plus 7. A sub k, the coefficients, are real numbers. The real numbers have to be coefficients. And k, the subscript, is going to be from 0 to n. So there's one more term than there is for an exponent, and n is going to be a positive integer. So a polynomial is a bunch of things being added together where they're powers of x, and the exponent must be a positive integer, and the coefficient has to be a real number. So linear combination means we're adding two different powers together, f of x and g of x, and it might be something like 3x plus 2x squared. The 3 and the 2 would be the a and the b. And this summation notation is a fancy way of saying that. So some terminology here, degree. The degree of a polynomial is the largest exponent in that polynomial. So we would call this example, this generic one up here, an nth degree polynomial. Quadratics are second degree. The constant term is the term that does not have a variable associated with it. And the leading coefficient is the coefficient of the term that has the largest exponent. And when we write the polynomial in standard form, we write them in decreasing order by exponent. So here are the powers of x, the first few of them. In general, let's look at what these are. So x to the 0 is a horizontal line on the x-axis. That's y equals 0. X to the first, we should know that one. Y equals x is that line. Y equals x squared, we should know is that. X cubed, we should have a decent handle on this one. It goes like that. Now as we get to the higher powers, the higher even powers, what happens is the sides steepen out and the bottom flattens out. You can envision like a pug. If you know what a pug is, a dog, they have a very smushed face. It looked like they ran into a wall. X to the 4th, x to the 6th, x to the 8th. It's kind of like running the tip of this quadratic into a wall and smushing it. Similarly with x to the 5th, these edges get steeper and the bottom gets flatter. Goes a little bit more like that. These are what we would consider even functions, and these are odd functions. Even functions are symmetric across the y-axis. Odd functions are symmetric through the origin. Maximum, minimum, those are words we should know. Highest or lowest point on a graph, or relatively highest point or lowest point. An inflection point is where the concavity changes. Concavity is, you can think of it as opening up, that's concave up, or opening down, that would be concave down. So with this cubic one, there's two types of concavity. This part here is concave up. You can picture a cup, it would hold water above it. This other part, this is concave down. You can picture an upside down cup here. So our inflection point is where it switches from turning upwards to turning downwards. That's our inflection point. These even functions don't have an inflection point. For cubic functions, there's two different types that we could have, and similarly for 4th degree, 5th degree, 6th degree, they can look a little bit different. We can either have this one that comes up, has its point of inflection, and then changes its concavity, continuing going up the whole time, or we could have one that has a local maximum and a local minimum. So it goes up, comes back down, goes back up again. These are both cubics, and it depends on the values, the coefficients of these terms as to whether or not we're going to have a continuously increasing function or one that has local maximums and minimums. Just be aware that it could look not always like this. So if we have polynomials and we want to add or subtract them, it's simply combining like terms. To multiply polynomials, we're using a process similar to when we multiply binomials. That's when we use FOIL. We expand them the same sort of way, except there's just more steps. To divide polynomials, we're going to use long division or something called synthetic division. We'll look at both of those in just a moment. I'm going to operate under the assumption that y'all can add and subtract polynomials. So we're going to jump in and we're going to solve this problem that involves multiplication. We want to find A and B, A, B, such that the product of f and g is this. All right, so what could we do? Well, let's multiply f and g. Let's expand this out. So x squared times x squared is x to the fourth. X squared times negative 4x, negative 4x cubed. And then plus bx squared. And then we go into the ax times each of these. So ax times x squared would be ax cubed minus 4ax squared plus abx. And then finally we do the negative 3 times each of those, so minus 3x squared. And then we have plus 12x. And then we have minus 3b. And we know that this has to equal x to the fourth minus 22x squared plus 9. And what we can do is we can equate the coefficients. So 4x cubed plus ax cubed has to equal, oh, there's no x cubed term here. So what that means is that negative 4x cubed plus ax cubed has to equal 0x cubed. So negative 4 plus a should give me 0. A is 4. Probably. We need to check the rest of these terms to make sure that this does indeed work, though. So now let's look at squared terms. Anything that has an x squared in it needs to add up to negative 22x squared. So bx squared minus 4ax squared minus 3 equals negative 22x squared. We really don't even need the x squareds here. We've got b minus 4a minus 3 equals negative 22. And we know a is 4. So b minus 16 minus 3 equals negative 22. b is equal to, if we add 19, b is equal to 3. And now to make sure that we're on the up and up here, we need to do some adding. We need to look at the rest of these terms. I'm going to look at the constant term. That term does not have an x, nor does that one. So we know that negative 3b has to equal 9. According to this, b should be negative 3. Oh boy, I got positive 3 back here. Well, that's because I wasn't careful. And when we add 19 to both sides, we get negative 3 for b. So this checks out. And we have one last term that we need to check. We should check the x terms and make sure that those all add up to 0x. And when we do this, it turns out it does work. So a equals 4 and b equals negative 3. Now let's divide. Ooh! We're going to divide 2x to the fourth plus 4x cubed plus 3x squared plus 2x minus 7 by x squared plus x plus 2. Okay, so this is the same thing as any other division problem, except it just looks different. So let's say for a minute, let's step away from that problem, and we'll go to 847 divided by, I don't know, how about 23? How many times does 23 go into 84? Well, that would be 3 times, I think. That's going to be 69. When we subtract, we get 115, and we bring down the 7. And now, so I found out how many times it went in there fully, and then I multiply these together to get here, and I subtract, and I repeat the process. Now 23 is going in here. Well, let's go back to our example. It's going to be the same idea, but I'm going to take that thing and figure out how many times I need to multiply it by to get this. Now we need to multiply by 2x squared. 2x squared times x squared is 2x to the 4th. And now just like in that number example, I'm going to take this value up here, this power, and multiply by this whole thing. I'm going to write it here. So we have 2x to the 4th, and then we have 2x cubed, and then we have plus 4x squared. And we're going to subtract, and those x to the 4th, that first term better go away. And then we have 2x cubed minus x squared, and we bring the next term down. Now, if there would have been a term missing, if this would have been, if I didn't have an x squared term, we would have to write plus 0x squared. We can't leave any of these terms out. And now we repeat the process. So now we're going to take the x squared, and it wants to become 2x cubed. What do we need to multiply by? We need to multiply by 2 times x. 2x times x squared is 2x cubed. And then we multiply it, we distribute it to the rest of this thing that we were dividing by. And we subtract. The x cubes will go away. We have negative 3x squared minus 2x minus 7. We bring that 7 down. Now we repeat the process again. This x squared, it wants to become negative 3x squared. So we need to multiply by negative 3. And we distribute that negative 3 through to the whole polynomial. And we subtract. The x squared term crosses out. We're left with x minus 1. So our division is equal to 2x squared plus 2x minus 3. This thing at the bottom is the remainder, and the way we should write it is plus x minus 1 over x squared plus x plus 2. And there we have it. There is our long division. In the next video that we look at, I'm going to show you a shorter way that sometimes works called synthetic division. Stay tuned for that wonderful joy.